All right, well, number 8, and this is the last installment of our integral calculus quick start guide. There's a second fundamental theorem of calculus that we need to also consider right here. It's a minor part, but one that needs to be remarked upon. If f of x is a continuous function on the interval from a to b, the closed interval, and the function f of x is defined by the antiderivative of f from the a to x of f of t dt, then f prime of x will equal f of x on that interval from a to x, which is to say, take the derivative of the integral from a to x, some fixed number to x of f of t dt, and the result will just be f of x. So, based on this rule, all we're really saying is that, all right, let's say that you were told to integrate from 1 to, take the derivative of the integral from 1 to x of the expression 2t plus 5 times dt. What should you get? Well, by this rule, you should just get 2x plus 5. What this rule really does is it connects the two worlds, one of the integration and the antiderivative, and the other one of the derivative. So we're connecting, we're saying that if you take the derivative of the antiderivative, you just get the original function back, which makes sense because if we had a function over an interval from a to x, whatever that function looked like, and here's a nice little curve, y equals f of x. If we start at a and we work our way over to x, and x could be anywhere from a to infinity. As we do, it's like we're unrolling a description of the area of this function, but what we're going to do is that if we take the area from a to x of f of t, and we're using t instead of x here, right, because x is already the endpoint there, so we're using a different variable t to do that. When we take that, we're getting that area under the curve. But lo and behold, if we take the derivative with respect to x of the area under that curve, all we're really getting is the function back that we started with. So that's our second fundamental theorem, and it gives us a quick way of dealing with this sort of situation.